EV batteries are made up of three main components: cathodes, anodes, and electrolytes. The materials in these components can be recovered through a number of processes, including pyrometallurgy, which uses heat to break down the battery into its various parts; hydrometallurgy, which uses acids or other aqueous solutions to leach out the metals from the battery; and electrowinning, which uses electricity to recover the metals from a solution. The process of recovering these materials is essential for two reasons. First, it allows us to reuse the materials in new batteries, reducing the need to mine for them. This helps preserve the finite supply of these materials and reduces the environmental impact of mining. Second, it allows us to reduce the cost of batteries, making them more affordable for consumers. So what actually happens to your EV battery when it's no longer useful? In this video, we're going to take a deep dive into the recycling process and find out. Welcome to our channel, where we explore the latest in green technology and sustainable living. Join us as we uncover the secrets of a cleaner, greener future. Don't forget to subscribe and hit that like button so you never miss an exciting episode. So let's start with the basics. What actually happens to your EV battery when it's no longer useful? Well, the good news is that most of the materials in an EV battery can be recycled. However, the bad news is that not all of them can be recycled. For example, lithium is currently not economically viable to recycle. However, recycling technologies are constantly evolving. So this may change in the future. So what happens to the battery itself? Well, when an EV battery reaches the end of its life, it's first transported to a recycling facility. At the facility, the battery is then dismantled and the various components are separated. These components are then processed to extract the valuable materials inside. Now let's take a closer look at each of these components and find out what happens to them. First, we have the cathode. The cathode is typically made up of nickel, cobalt, manganese, and aluminum, as well as other materials such as lithium and iron. These materials are valuable and can be recovered through various processes such as pyrometallurgy, hydrometallurgy, and electrowinning. Pyrometallurgical processes use high temperatures to break down the battery's various components. This process is effective at recovering materials such as nickel, cobalt, and manganese. Hydrometallurgical processes, on the other hand, use aqueous solutions to leach out the metals from the battery. This process is well suited for recovering lithium and iron from the battery. Electrowinning is another process that can be used to recover metals from a solution. This process uses electricity to deposit the metals onto a cathode, which can then be recycled. Next, we have the anode, which is typically made up of graphite and copper. Graphite is a form of carbon and it can be recovered through a process known as calcination. Calcination involves heating the battery material to high temperatures, which breaks down the graphite and other organic materials, leaving behind a concentrated amount of carbon. This carbon can then be used in the production of new batteries. Copper, on the other hand, is a highly valuable material that can be recovered through various processes. One common method is known as smelting, which involves heating the battery material with a flux to form a slag. The slag is then separated from the raw copper, which can be recycled. Finally, we have the electrolyte, which is typically made up of lithium salts and other materials such as aluminum and cobalt. The electrolyte's primary function is to facilitate the transfer of ions between the cathode and the anode. This process allows electricity to flow through the battery and power the electric vehicle. The electrolyte is a complex mixture of materials, and recovering them requires specialized processes. One common method used to recover the materials in the electrolyte is known as solvent extraction. This process involves using organic solvents to selectively extract the desired materials from the electrolyte. Once the materials have been extracted, they can be purified and reused in the production of new batteries. In addition to these processes, there are also some emerging technologies that hold promise for the future of EV battery recycling. One such technology is the use of artificial intelligence and machine learning to optimize the recycling process. AI and ML algorithms can analyze data from various sources to identify the best methods for recovering materials from different types of batteries. They can also help to automate the recycling process, which can improve efficiency and reduce costs. Another promising development is the use of robots and automation to handle the physical aspects of recycling. Robots can be programmed to disassemble batteries, sort materials, and perform other tasks that are currently done by hand. This can help to improve safety and reduce labor costs, making the recycling process more cost-effective. But why should you care about battery recycling? Well, for starters, it's simply the right thing to do. The materials in batteries are valuable and should not be wasted. By recycling them, we can reduce the demand for new materials, which in turn reduces the environmental impact of mining. Additionally, recycling of batteries can help to reduce the cost of batteries, making them more affordable for consumers. Cheaper batteries mean that more people will be able to switch to EVs, which can help to reduce greenhouse gas emissions and improve air quality. However, it's important to note that not all batteries are created equal. Different types of batteries use different materials and have different chemistries. This means that the recycling process can vary depending on the type of battery being recycled. For example, lithium-ion batteries used in most EVs today cannot currently be recycled at all due to the low concentrations of critical materials. In fact, only 5% of lithium-ion batteries in Europe are being recycled. But don't worry, as we mentioned earlier, recycling technologies are constantly evolving and lithium recycling plants are already under construction in China and the US. So what can you do to help improve battery recycling? Well, one way is to support companies that are working to make recycling more efficient and cost-effective. There are many startups and small businesses that are developing innovative recycling technologies, and they need our help to succeed. Another way you can help is to stay informed about the issue and raise awareness among your friends and family. The more people who understand the importance of battery recycling, the more likely we are to see action. Finally, you can also contact your local elected officials and urge them to support policies that promote recycling. By working together, we can ensure that the valuable materials in batteries are recovered and reused, reducing the demand for new materials and lowering the cost of batteries for consumers. And if you want to learn more about the latest developments in battery recycling, stay tuned to our channel for more updates. We'll be covering everything from new recycling technologies to the latest industry news. Now let us take a look at some of the companies that are leading the way in battery recycling. One company that's making waves in the industry is Redwood Materials, a US-based company that was founded in 2017 by former Tesla executive J.B. Straubel. Redwood Materials uses a process known as disassembly and direct lithium-ion extraction to recover valuable materials from spent batteries. The company has developed a proprietary process for extracting lithium, nickel, cobalt, and copper from battery materials without the need for harsh chemicals or high temperatures. Another company making strides in battery recycling is Battery Resourcers, a UK-based company that was founded in 2016. Battery Resource uses a process known as hydrometallurgy to recover valuable materials from spent batteries. Hydrometallurgy involves using aqueous solutions to leach out the metals from the battery. Battery Resources process is particularly well suited for recovering lithium and cobalt from batteries. In addition to these companies, there are also a number of other startups and small businesses that are working to develop innovative battery recycling technologies. These companies are exploring new methods such as using supercritical fluids to extract battery materials and using microorganisms to break down battery components. The field of battery recycling is still in its early stages, but it's rapidly evolving. As the number of EVs on the road continues to grow, the demand for battery recycling services will also increase. This presents a huge opportunity for companies that are able to develop efficient, cost-effective recycling technologies. In conclusion, battery recycling is a critical part of the electric vehicle supply chain. By recycling these batteries, we can reduce the demand for new materials, lower the cost of batteries, and reduce the environmental impact of mining. While there are challenges associated with recycling different types of batteries, companies are working to develop innovative solutions that can overcome these challenges. As the number of EVs on the road continues to grow, the demand for battery recycling services will also increase, creating opportunities for companies that are able to develop efficient, cost-effective recycling technologies. So what do you think of the future of battery recycling? Do you think we'll be able to recycle all types of batteries in the future? Let us know in the comments below. Thank you for joining us today. If you enjoyed this video, please don't forget to give it a thumbs up and share it with your friends and family. Subscribe to our channel for more exciting content. We look forward to seeing you in the next video.